Hello, Pre-Calc BC. Today we are going to be talking about hyperbolas, and we are going to be doing the first side of the day 6 notes and the first side of the day 7 notes. So first of all, let's talk about what the technical definition of a hyperbola is. It is a collection of points where the difference in distances to the two foci is equal to 2a. If you recall, for ellipses, it was where the sum in distances to the foci were 2a. So this is what a hyperbola looks like. It is a lot more complicated than ellipses and parabolas. The actual hyperbola is what I'm highlighting here in green. And then everything else we use to go ahead and to actually graph the hyperbola. So let's identify what our A, B, and C values are. So our A value is the distance from the center to what we call the vertex. And we've got this written down below. So for right now, just label. So we have a center. We have two vertices. We also have two non-vertices, which are these dots up and down. Non-vertex. It's down here. Non-vertex. So this would be your B value. And then we also have foci. Foci are always going to be inside of the hyperbola. And then I don't really have room to label it, but our C value is again going to be from the center to the foci. And then these blue dotted lines are asymptotes, and we are going to need to go ahead and draw those in order to accurately draw the hyperbola. So, all right, that's some of the information that we have. Let's go ahead and write down some more. All right, so first of all, here is an equation in graphing form of a hyperbola. And what you're going to notice is that it does have a shift already. So our center is going to be at 2, 1. You're also going to notice that this looks very similar to the equation of an ellipse, except you have a minus in the middle, and that's the big difference here. Now, here are your general forms. I'm going to be honest, I don't use this one for the same reason that I don't use that form for ellipses. I think people mess up their centers. So because of that, you're going to notice that in both of these, the a squared comes first. When I write my equation, a squared isn't necessarily coming first. The way you know which one is a squared is which value is positive. And so for example, here, this is a minus. The minus is going with the y. So that means this is the positive one. And so the a value is with the x. So just bear with me. Okay, well, it will make more sense as we do this. So it's not necessarily the biggest value. That's what's different about hyperbolas and ellipses. You're going with whichever one is the positive. And this is from the distance from the center to the vertex in that direction. So again, because the minus is with the y, this is b squared. The a squared is always the positive one. So our a is going to be 3, and it's going to go in the x direction. All right, so we're going to go ahead, we're going to plot our center like normal. And then what you're going to go ahead and do is you're going to count 3 to the right and 3 to the left. And these are going to be your vertices. Okay, so I have a vertex at 5, 1 and at negative 1, 1. All right, so your a value gives you your vertices. So then our b, the way we're going to find our b is that it's the one always with the negative. So here's the negative, it's with the y, so this one is b squared. It's going to be the distance from the center to the non-vertex. So b is going to be 4 in the y direction. So you are going to go up 4 from the center. 1, 2, 3, 4, and down 4. So that's going to give you your non-vertices, which I just call non-v. And those non-vertices are going to be at 2, 5 and 2, negative 3. All right, so the difference between the vertices and the non-vertices is that the hyperbola actually gets drawn from the vertices. So what's the point of these non-vertices? Well, if this were an ellipse, you would just connect the dots and you'd move on with your life, but this is not an ellipse, it's a hyperbola. So what you're going to do is you're going to create a little box with the vertices and the non-vertices, like so. Then what you're going to go ahead and do is you can use a ruler if you would like. I have plenty in the classroom in this little brown Jolly Rancher box randomly, which you can find either on my desk or it might be over by the calendar, or you can just kind of freehand it. You're going to do the diagonals of the boxes dotted. These are called your asymptotes. We mentioned those above. And the reason we need to draw these is because this helps us actually draw in the hyperbola. All right, so now what you're going to do is you're going to find your vertices, which again were the ones on the X. This is kind of like, think about if you were drawing a parabola, this would be the vertex of the parabola. But what's important is you've got to actually follow the asymptotes. So it's not like this, all right? It needs to be going towards the asymptotes, all right? So watch. Oh, I just lost it. It's going to be like this. All right, so because the X is the one with the positive, that's why your hyperbola is going left and right. Okay, so now we still need to find a few more things. C is still our distance from the center to the foci. The foci are always inside the hyperbola. And the way that we're going to find our foci is using c squared equals a squared plus b squared. So just like the equation has a different sign than the hyperbola, your c equation also has a different sign than the one you use with, I think I just said that backwards. Okay, ellipses, the equation of an ellipse has a plus, but the c squared equation has a minus, and so it's switched for a hyperbola. The equation of a hyperbola has a minus, so the c squared equation has a plus. Okay, hopefully that made sense. So we're just going to say c squared equals 9 plus 16 and solve, and c is 25. Oops, I'm sorry, c is 5. And so what we're going to go ahead and do is we are going to go 5 units from the center inside the hyperbola. So we're going to go left and right. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Okay, a couple mistakes people make. You're not counting from the vertex, you're counting from the center. So it's the same thing as with ellipses. And just like with ellipses, how the foci is always on the major axis, the foci for a hyperbola will always be inside the hyperbola. So our foci are at 7, 1 and negative 3, 1. All right. So there are 3 more things, unfortunately, that you have to list for hyperbola. So hopefully you have some space. And those are the asymptotes, as well as something called the transverse axis. Oops, what'd I do? In general, people call this the t-axis. And finally, the conjugate axis, which a lot of people call the c-axis. None of these are very difficult to do. It's just, there's a lot of information to write down. So for the asymptotes, the information that you need is you need a slope and you need a point. And fortunately, you have both of those things. The point that we're going to use for our asymptotes is the center, so that's 2, 1. And the slope we can find with our a and our b value. So just count from the center up how many. We went up 4, and over how many. We went over 3. So our slope is 4/3. However, because you have this asymptote going the other direction as well, we also have a slope of negative 4/3. So we're going to have plus or minus 4/3. Now we're just going to go ahead and we're going to write the equation of the asymptote in point slope form. So you'll have y, and then the opposite of your y coordinate equals your slope. Don't forget about the plus or minus. And then x, and the opposite of your x coordinate. And this is the equation of your asymptotes. You do not need to solve for y. Please just leave it like this. All right, next we're going to talk about the transverse axis. The transverse axis is essentially just an axis of symmetry that goes through the hyperbola. So always goes through, T for through. So this is the t-axis. It goes right through the center every single time through the actual hyperbola, and so the equation of this is y equals 1. And then the conjugate axis is essentially an axis of symmetry, but it goes the other way. So it goes this way through the center still, and so this would be x equals 2. All right, so pertinent information for hyperbolas. There's a lot. We have a center. We have 2 vertices. We have 2 non-vertices. We have 2 foci. We have the equation of the asymptotes. And then we have your t-axis and c-axis, which some people refer to as taxis and caxis. Okay, so you need all of those when you have a hyperbola. Isn't that exciting? All right, so now we're going to go ahead and we're going to switch gears to the other note sheet where we are going to talk about how to put these equations into graphing form and then actually practice graphing them. So we're just going to go ahead and do the front. Now, if you're interested in looking at the other problems that we are skipping, you can go ahead to the module and you can find the full videos for each lesson. This is just a new video I'm recording so that you don't have to bounce back and forth between videos and you have everything you need in one place. But if you're interested in seeing the whole video of each of these lessons, just check out the module in Canvas. All right. So we're going to take a look at number 1. Number 1 is already in graphing form, so this is like the one we just did. We're just going to practice finding all of the important information and listing it and graphing. So the first thing that I want you to notice is that, again, this minus belongs with the y. Okay, and so because of that, this one is the positive, and that means that this is going to be a left and right hyperbola. That means that this guy is my a squared. A is 2. B is 3. My center is going to be at 2, negative 3. My a value is 2 and it's underneath the x, so I'm going right 2 and left 2. Those are going to be my vertices. So that's at 0, negative 3 and 4, negative 3. My b value is 3. I'm going up 3 and down 3. Those are going to be my non-vertices, and those are at 2, 0, and 2, negative 6. All right, so now you are making a little box. And it should be dotted because it's not actually a part of the hyperbola. You're just using it to draw the hyperbola. And then using a ruler, or if you are really good at drawing lines freehand, you're going to draw in your asymptotes. Okay, and then again, because your x is the positive one, that means that our hyperbola is left and right. So now you can go ahead and actually draw in that hyperbola off of the vertices. Okay, so now what I would recommend we do next is find our c value so that we can find our foci. So c squared is equal to a squared plus b squared. And that's going to be 4 plus 9, which is 13. And c is going to be equal to the square root of 13. So square root of 13 is more than square root of 9, but less than square root of 16. So it's going to be right between 3 and 4. And again, it's going to be inside the hyperbola. So count from the center, and you're going 3 point something to the left and to the right. 1, 2, 3, point something. 1, 2, 3, point something. It's very annoying when it does that. Okay. All right, so now we're going to actually go ahead and list those foci. Because we have a root, I'm just going to write it as one ordered pair here with a plus or minus. So it's my x coordinate that changed from the center. So my x coordinate was at 2, and I'm going plus or minus root 13 because I'm going root 13 to the right and root 13 to the left. My y coordinate stayed the same, so my y coordinate is still down at -3. All right, the last thing we have to do is write the equations of our lines. So we have the asymptotes. Again, the asymptotes, you need two things for it. You need your slope, which we're going to find by counting up and over. We went up 3, we went over 2. So my slope is 3 over 2, plus or minus 3 over 2. And then my center is at 2, -3. So we're going to do y, and then the opposite of the y coordinate is equal to the slope, plus or minus 3 over 2. And then x and the opposite of the x coordinate. All right, and finally we're going to write the equation of taxis and caxis. So taxis, t-axis always goes through the hyperbola and always through the center. So our t-axis, our equation in this case is y equals -3. And our c-axis just goes the other way, also through the center. And that's going to be x equals 2. Now, if you don't like how much stuff there is here, it's okay if you don't want to draw the t-axis and the c-axis, but you do need to draw everything else. Okay, I need to see the asymptotes drawn, but t-axis and c-axis, if you just want to write them down but not put them on your graph, that's okay, because I know there's a lot on there. All right, so now we're going to go ahead and we're going to try the next one. This one, in order to get our graphing form, we're going to have to divide everything by 9. Y plus 4 squared over 9 minus x minus 3 squared over 1 equals 1. All right, now you can leave it like this if you'd like, but like I've said in the past, I think people mess up their center, so I'm going to rewrite this so that the x comes first, and I want you to notice that now the negative is with the x. And that means that the plus is with the y. And since the plus is with the y, what that means is that this is going to be an up and down hyperbola. Okay, I've kind of taken up a lot of space there. Let's make that smaller. Okay, so now let's go ahead and start finding everything and graphing everything. Okay, center comes first. Center is at 3, -4. Now again, if you want to leave it like this with the y first, that's fine, but make sure that you do 3, -4 still for your center. All right, now we're going to go ahead and we're going to find our a value. Our a value is always the positive. So plus this is our a squared value. So a is 3, and that means because the a is underneath the y, that means that I'm going 3 up and 3 down. Those are your vertices. So that's where the hyperbola is going to come off of, and that's at 3, -1, and 3, -7. Your b value is always the one with the negative. So b squared is 1. That means b is 1. And that means since it's under the x, we're going to go left and right 1 from the center. Those are your non-vertices. 4, -4. 2, -4. All right, now you're going to draw the box. Then you're going to draw on your vertices, or sorry, not your vertices, your asymptotes. Okay, now please be careful. The vertices were 3, -1 and 3, -7. Again, this hyperbola is up, down. So you are drawing it like this. Next, we're going to find our foci, which means we need our c value. C squared equals a squared plus b squared. So that's going to be 9 plus 1 is 10. And c is going to be square root of 10. Square root of 10 is just a little bigger than square root of 9, so just a little more than 3. But keep in mind, again, it needs to be inside the hyperbola, so you're going to go a little more than 3 up and down from the center. All right, again, since we're dealing with a square root, I'm just going to write this as one ordered pair just to make my life a little easier. It's the y coordinate that's changing. I moved up and down, so my 3 from the center stays the same, and then my y coordinate is going to be -4 plus or minus root 10. All right, we're in the home stretch. Now we're going to go ahead and do the equations of our lines, the asymptotes, and then the t-axis and c-axis. So again, the asymptotes, you need your center and you need your slope. So our center is our point. Our slope is up 3 over 1. So I have y, opposite of the y coordinate, equals plus or minus 3 over 1 is 3, x, and the opposite of the x coordinate. So those are the equations of the asymptotes. And then t-axis, this is the one that goes through the hyperbola. Again, you don't have to draw this, but this time the one that goes through the hyperbola is the vertical one. So that's going to be x equals 3. And the c-axis is going to go the other way through the center. Again, you do not need to draw this. That's going to be y equals -4. All right, and there's all your information. And we've got one left. Okay, so this one, we need to go ahead and we need to not only put it into graphing form, but then do everything else. So what I'm going to recommend is that you do the graphing form with me and then pause the video and then try doing the rest of it yourself and then checking the answers to see if you're right. So in terms of putting this in graphing form, it is the exact same thing as what we do with parabolas, except you're going to have a minus. So first, I like to organize everything. And subtract your 4 over. The x squared, I can just go straight to completing the square, so I'll get to that. Please be careful, you're taking out a -3, so this becomes y squared plus 2y. Yes, that is something people make a mistake on. All right, we're completing the square. 8 divided by 2 is 4. 4 squared is 16. It's just a 16, so I'm adding 16 over here. 2 divided by 2 is 1. 1 squared is 1. But it's 1 times -3, so I'm subtracting 3 over here. Factor. Oops, that's y. -4 plus 16 is 12. 12 minus 3 is 9. And then finally divide everything by that number on that side so we can get an equals 1. X plus 4 squared over 9 minus y plus 1 squared over 3 equals 1. Okay, again, whichever value x or y is positive, that tells you the direction the hyperbola is going, and that also tells you which is your a and your b values. Sorry if you hear weird noises, my microphone thing is uncooperative. So the minus is with the y, that means the plus is with the x, that means it's going to look like this. That also means this is my a squared value, and this is my b squared value. All right, so now see if you can pause and go ahead and find everything. And I will go ahead and just record the video. So when you're ready to check your answers, you can click play again. All right, go for it. Okay, I'm just going to erase some stuff so I have more room because I write too big. All right, hopefully at this point you already have something on your paper and now you're going ahead and checking everything. You should have a center at -4, -1. And then my a value is going to be 3, and that's going to be to the left and to the right. And those are going to give me my vertices. So my vertices should be at -7, -1, and -1, -1. My b value is a square root of 3. Yes, that's a little gross. So that's just a little less than 2. Do your best. Oh, come on. There we go. Okay. And so my non-vertices are going to be, you're going to name this the same as we did with foci when you had square roots. It's your y coordinate that's changing from your center. So it's still a -4, but then it's -1 plus or minus root 3. So those are your non-vertices. All right, now you're going to draw the box. Then you're going to draw on your asymptotes. Okay, and again, I'm kind of writing over where I'm going to draw my hyperbola. So my hyperbola is going to go left and right. So from the vertex, you are going like this. I should have put this stuff on the other side. Oops, I took part of my hyperbola with me. Okay. All right. So now let's see. Now I'm going to find my foci. So to find my foci, I have c squared equals a squared plus b squared. 9 plus 3 is 12. So c is square root of 12. This is going to be 3 point something. Okay, something between 3 and 4. So you're starting at your center and you're going 3-ish to the left and right. 1, 2, 3-ish. 1, 2, 3-ish. All right, so when we name our foci, just like we did with our non-vertices, we're moving left and right. So your x coordinate will change, your y coordinate will stay the same. This is from the center. So -4 plus or minus root 12, or you could say 2 root 3. Y coordinate is staying at a -1. All right, you're in the home stretch. Asymptotes. We have our center and then our slope. We went up root 3 and we went over 3. Notice that that's based on your a and your b value. It's going to depend whether it's a over b or b over a based on which direction your hyperbola is going. So just think of up divided by over. We went up root 3, we went over 3. So root 3 over 3 will be our slope. So I'll have y plus 1 equals plus or minus root 3 over 3, x plus 4. Again, that was up root 3 over 3. And then finally, taxis and caxis. T-axis goes through the hyperbola. That's going to be a horizontal line. So that's going to be y equals -1. And c-axis goes the other way through the center, and that'll be x equals -4. And again, you should notice it's just using the points of the center, x and y, because every time you draw those lines, they are always going through the center. All right, so there you go. That is your hyperbolas lesson. So the homework that we are doing for hyperbolas is we are just going to do day 7 homework. We are not going to do day 6. If you feel like doing day 6, you are more than welcome to, but the types of problems you'll be assessed on are more like day 7. So we're going to focus on day 7, and we're only going to do the 49 to 57 odd. The 65 and 67 are applications of hyperbolas, which we did not talk about. And since we did not talk about them, no, they will not be assessed on. So again, the assignment is day 7, 49 to 57 odd. Anything else would be considered optional. Day 6 homework optional. 65, 67. If you want to go ahead and watch the rest of the video that's on the Canvas page, you can. If you're interested in looking at how to do those, it turns out sonic booms actually are an application of hyperbolas. So if that is interesting to you, you can go ahead and watch the other video to see that. But otherwise, I hope you have a wonderful 3-day weekend, and I will see you on Tuesday. Bye.